Today we're going to cover section 3. Today we're going to learn how to calculate area of polygons. So you should already know from your prior knowledge from probably elementary and middle school how to calculate the area of a square. You're going to either memorize it as side squared or length times width or base times height. The only thing is with a square is all four sides are the same. Same thing for a rectangle. It's either length times width or base times height. And then we've been doing the triangles a lot. That's been 1/2 base times height. Now here's another formula that you can use to calculate the area of a rhombus or a kite. All you need to do is take the two diagonals, multiply them, and then multiply that product by 1/2 or divide it by 2. It doesn't matter which diagonal is named as diagonal 1 or diagonal 2, because remember, multiplication is commutative. It doesn't matter the order that you multiply two numbers. And this formula is actually formulated by finding the two congruent triangles that are here and then finding their areas individually and then doubling them. But again, you don't need to know how the formula is come up with. You just need to know that it's 1/2 diagonal 1 times diagonal 2. So let's go ahead and try 2 examples using this formula. So the first picture is a picture of a rhombus. Notice all four sides are congruent. So I'm going to be using the formula. Area is equal to 1/2 D1 times D2. Now, if you'd rather, you could also do D1 times D2 and divide it by 2. Either formula. Now, again, it doesn't matter which one that I label as D1 and which one is D2. So I'm going to say the 6 is going to be my D1 and the 8 will be my D2. So 1/2 6 times 8. And then I'll go ahead and multiply. And again, you could take 1/2 of 6 and then times it by 8. Or if you would have preferred to do 8 times 6 and then divide it by 2, you can do that way as well. But this actually gives me 24 meters squared. Remember, the units on any area question are always going to be squared. The second picture is a kite. However, it's still going to use the same formula. So again, I'm going to label the 10 as my D1 and my D2 will be the 7. And I'm going to plug it into the formula. So 1/2 10 times 7. 1/2 of 10 is 5, and then 5 times 7 is 35. And these were centimeters, so it's centimeters squared. So just another formula that you can use to calculate the area of a rhombus or a kite. Now, here's where the fun part begins. We're going to be calculating the area of any polygon, and it could be a hexagon, a decagon, a nonagon. But before we can learn that formula, we need to know about some vocabulary. So these are going to be the parts of the regular polygon that we're going to need to identify in order to find the area of a polygon. So the first thing is the definition of a center. Just like a center of a circle, it's going to be that middle point. So the center of the circumscribed circle. The second vocab word is the radius, and the radius is going to be the radius of the circumscribed circle. It's also the distance from the center to the vertex. And then the next one is called the central angle, and that's going to be an angle that's formed by two radii and that are going to be drawn to two consecutive vertices. Then the next vocabulary word is called the apothem, and that is going to be the perpendicular distance from the center of the polygon to a side. So let me zoom into my picture, and I'm going to talk about these 3 vocabulary words based on the picture that's given. So you can see that the center is already labeled for us. The center in this picture is point P. Then the next thing that we talked about was a radius. And the radius by definition here said it's the radius of the circumscribed circle. And it goes from the center to a vertex of the polygon. So I have a radii that is drawn right here and here. I could draw in radii to each one of the vertices. I can draw one here, 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 and here. The figure that's in here is a hexagon. It's got 6 sides. The next thing that it was defined is the central angle. Same central angle that we talked about before, it's just an angle with its vertex at the center. However, to find the measure of the central angle, what we're going to learn on the next slide is you would take 360 and divide it by the number of sides. If you notice, I've just now drawn in 6 central angles here because this is a 6-sided figure. And then the next thing is called the apothem, and the apothem is the blue line that's in here, and it's the perpendicular distance from the center to the side of the polygon. It does not go all the way to the circle. The radius is always going to be longer than the apothem. Notice if you look at this, this is like a little right triangle here. And notice the radius is actually the hypotenuse. So let's go ahead and learn how to figure out what the measurement of that central angle is by looking at the next slide. So the central angle can be found by, and this is only for a regular polygon, and remember back from your prior chapters, regular polygons are polygons that have all the same side lengths and all the same angle measures. So in that prior slide, that picture was a hexagon. You need to know that a hexagon, the number of sides in it is 6. So to find the measure of that central angle, you're going to take 360, divide it by the number of sides, and the measure of that central angle is going to be 60 degrees. If it were a square, you know that a square has 4 sides. So your n value is 4, and you will take 360, divide it by 4, and the central angle in a square is going to be 90 degrees. Now let's go ahead and do some examples where we're going to identify the center, the radius, the apothem, and the central angle. So in this picture, we have a square that is inscribed in circle P. It wants me to identify the center. The center is right here. It's point P. So the center is point P. Then it wants me to identify a radius. Well, pictured right now, I have 2 radii drawn in here. I have a radius that is going to go from P to Y. That's one of them. And then I also have another one that's going from P to X. I could actually draw in the other 2 because, again, remember, the radius will be drawn from the center to the vertex. So I could also draw another radii from P to Z and P to W. Then it also wants me to identify the apothem. The apothem is the perpendicular distance from the center to the side of the polygon. So my apothem is going to be segment PQ. And then lastly, it wants me to name a central angle. Well, based off of the original radii that were drawn in, this is my central angle here with its vertex at the center. So the central angle, you could name it of the one that was originally pictured as XPY, or you could go in reverse and call it YPX. Now there's actually 4 central angles here, but again, I just wanted to refer to the one that was there before I drew in those other 2 radii. Now, we've already identified all of the parts. Now we're going to find the measure of some angles in this picture. Now, notice the first one, they want me to find the measure of XPY. XPY is this central angle. We just learned the formula on the prior slide. So to find the measure of angle XPY, I take 360, divide it by the number of sides in my polygon, and that will tell me that XPY is 90 degrees. Next, they want me to find the measure of XPQ. XPQ is actually this piece of the 90-degree angle. Once you draw in that apothem, it's a perpendicular bisector. So it's going to split this 90 degrees into 45 and 45. So this is actually a right angle right here. And then it splits the XPQ into 45 degrees. So XPQ is 90 divided by 2, and it's 45. And then the last angle they want me to identify is angle XP or PXQ. And that one is located over here, down here at the bottom. Now again, if you realize this is a little right triangle here, and if you pull it out, let me do it in a darker color. We had the 90 degrees. We had this 45 that was split. So this is actually a special right triangle, and this XPQ is now also 45. So we're bringing back special right triangles. If the central angle, once you bisect it, if it does not turn into a 30, 60, 90 or a 45, 45, 90 triangle, that's when we're going to use the trigonometry. And the only polygons where we're going to use the special right triangles are going to be hexagons, squares, and equilateral triangles. All the other polygons, we're going to use the trigonometry. So let's see what the formula is to find the area of any polygon. And that is going to be 1/2 the apothem times the perimeter. Or if you don't already have the perimeter calculated, then it's the bottom formula, the 1/2 ANS, where A is the apothem, the capital P is the perimeter of the polygon, the lowercase n is the number of sides in your polygon, and S represents the side length of the polygon. So in the next examples, they're going to ask you to calculate the perimeter. Perimeter, remember, is adding up all the sides. But the fastest way to do it, because it's going to be a regular polygon, just take the number of sides and times it by the side length. Because if you notice the difference between the two formulas, this one has the capital P, this one is just replacing capital P with the formula, number of sides times side length. Coincidentally enough, on all of our examples we're going to do, I'm going to figure out the perimeter first, so I'll be able to use this first formula. However, if you get a question where it just says find the area, you're not going to necessarily have to find the perimeter first. You can just plug it into the second formula. Now also keep in mind, if you didn't want to use the 1/2, for example, the bottom formula, you could also do apothem times number of sides times the side length and divide it by 2. It's the same thing as multiplying by 1/2. So either way. In the past, we did not use calculators. We left everything in simplest radical form or in terms of pi. However, because big ideas want so many of the answers left rounded to the tenths place or the hundredths place, this is why we're using calculators. But traditionally, we do not use calculators for this chapter, which makes it even more challenging. So you guys have a little advantage here. So let's try some examples using these two formulas, the area formula and the perimeter formula. So the first one is asking us to find both the perimeter and the area of this regular hexagon. All they've given us is the apothem. So remember, the two formulas we're going to be using is perimeter, number of sides times side length, and then the area formula is 1/2 apothem times perimeter. So if you notice, the three variables that we need to find the value for are going to be the n, And this one I can tell from the name. It's a hexagon, so n represents the number of sides. They gave me the apothem. The only thing I don't know yet is that side length. And this is where I'm going to use my special right triangle. So I'm going to go ahead and draw a picture of a hexagon. Again, I am not going to ask you to draw figures and grade you on your pictures. Just give yourself a rough sketch of a hexagon. What I like to do is draw 6 little dots. Try to space them out as evenly as possible. And then connect them. And this is my hexagon. Now, a circle is also surrounding this, so this is a circumscribed. A circle could be circumscribed about this hexagon, but all we really need to focus on is adding in the center and then drawing in the radii. And the radii go from the center to each vertex. The next thing I need to do is calculate my central angle measure. So remember, we take 360, divide it by the number of sides, and the central angle right here is going to be 60 degrees. I also need to draw in the apothem. Once I draw in the apothem, it's going to bisect that 60. So what I'm going to do is I'm going to pull that triangle out of the hexagon so we can zoom into it and focus on it a little bit better. So let me go ahead and draw the 2 radii, and then the side, draw in the apothem. Remember, originally, this angle up here was 60, but remember, it's been bisected, so now this is 30, and if the bottom is 90, then this other missing angle is 60. I now have a special right triangle that I'm going to use to find the length of the side. The length of the side is this whole thing right here. But first I'm going to just focus on the right side of the triangle. So if I pull it out again, just so you can focus on it a little bit better. Now, once I figure out that black side on the bottom, that's going to only be half of the side of my hexagon. I'm going to have to double it once I'm done. So I'm going to go ahead and fill in. Now, we're going to reach back to our special right triangles. Remember back when we did it, the side across from 30, I would always call this A, and then the 60 was A root 3, and then this was 2 times A. So we don't get confused with the apothem. I'm going to change the variable to an x. And instead, I'm going to call this x, x root 3, and then 2x. Because once you're solving for a, you may think that that's the apothem. So it's better if we change the variable to the rules that we're going to memorize for these special right triangles and change it to an x. So now, what was given to us was that apothem length, and it was 6. So the apothem is the blue line. So I know that x square root 3 is equal to 6. I need to solve for x because I'm trying to find the length of this side over here. So let me go ahead and solve the equation. X square root 3 equals 6. I'm going to divide both sides by the square root of 3. 6 over the square root of 3 is what x equals. I need to rationalize. I cannot leave my radical in the denominator. So I'm going to multiply the top and the bottom by the square root of 3. And now I'm left with 6 square root 3 over 3. I can simplify this, and this becomes 2 square root 3. That is what x equals. So remember, that's the amount for this side and this side. So to find the side length of my hexagon, I need to add 2 square root 3 plus 2 square root 3. Or you could also take 2 square root 3 and times it by 2, because you got to double it, so it turns into 4 square root 3. That might be faster, But again, when you add two radicals, you don't add the radicals, treat the square root of 3 like a variable, and then just add the 2 plus 2. So now I have the value of s, it's 4 square root 3. Now I have the value of the 3 variables that I need for the 2 formulas. So now I'm going to do perimeter first. So the formula for perimeter is the number of sides times the side length. It's a hexagon, so my n value is 6. And now my side length is 4 square root 3. I'm going to multiply 6 times 4 square root 3, and I get 24 square root 3. Remember, perimeter is only units, just like circumference. Now, if it said to leave your answer exact, that's your answer. If it says simplest radical form, that's your answer. If it says round to the hundreds place, then you're going to need to multiply 24 times the square root of 3. And once you do that, you should be getting 41.569. So we're going to round it to 41.57. And again, these are still units. So these are the two answers. Again, read the directions when you do the homework of how they want you to leave it. Now that I've calculated the perimeter, now I can find the area. So the area formula, since I have the perimeter, I'm going to use the 1/2 apothem times perimeter. Do not use the rounded answer if you're asked to find the area and perimeter. Go back to the radical. So it's 1/2 apothem, which was 6, times perimeter, 24 root 3. So in simplest radical form, this is actually going to give me, once I multiply 1/2 times 6 times 24 square root 3, gives me 72 square root 3. Area units are always squared. Then if I wanted to find it rounded to the hundreds place, multiply 72 times the square root of 3. And that should give you 124.707, so 124.71 units squared. So again, depending on what the instructions say, if it's exact, it's the first one. If it's rounded to the hundreds place, it's the second one. Now, for the next one, they have given us all 3 of the variables. Octagon, you need to know that it's 8 sides. So your n value is 8. The side length is 5. It's given to us. And the apothem is 3. Now, if they did not give me all 3, once I drew the octagon and then pulled the triangle out, I would not be able to create a special right triangle. I would have to do trigonometry. I would have to use sine and cosine. However, I'm going to do an example where I'm going to have to use the trig on the last example in the notes. But for now, since I have everything I need, I'm just going to plug it into the formula. So perimeter again, number of sides times side length. Number of sides is 8, side length is 5. 8 times 5, and the perimeter is 40 units. For the area, 1/2 apothem times perimeter. My apothem is 3. My perimeter is 40. 1/2 times 3 times 40 gives me 60 units squared. So for this one, there wasn't any square roots. It was actually just the single answer for both. Next one, I draw an equilateral triangle. Okay, so here is my triangle, and I'm going to draw in the center. I'm going to draw in 2 radii, because again, it goes from the center to the vertex. I need to find the measure of this central angle up here. I take 360. I divide it by the number of sides in my polygon. Triangle has 3 sides. 360 divided by 3 is 120. So this angle is 120 degrees. Once I draw in that apothem, it's going to bisect that 120, and that top angle would now be 60. So let me go ahead and pull out this little side here. Let me actually pull out the whole thing. So let me go ahead and pull it out. Here's the two radii. Here's the side length. Here's the apothem. Up here is 60 because the 120 was bisected. And then the 30 would be over here. They gave us the length of the apothem this time. So if I redraw just the one side of the triangle, I've got an 8 here. I know that that is going to be the side across from 30, so it's x. Then the side across from the 60 is x root 3, and this would have been 2x. I just need to find the side length, because remember, we're trying to find n, which we know it's 3. The a, it's 8. We're trying to find s again. So now that I have the apothem, all I'm going to do is take that 8, put it right here. And this side, or half of the side of the triangle, is 8 square root 3. So remember, I've just found this side, and now this side. And again, either add it or double it. So once you add 8 square root 3 plus 8 square root 3, the entire side of the triangle is actually 16 square root 3. So now that I have the value for the 3 variables, now I can plug them into the formulas. So for the first one, the perimeter, number of sides times the side length. Number of sides is 3, it's a triangle. And then the side length is 16 square root 3. Multiply 3 times 16, and you get 48 square root 3 units. Using my calculator and rounding to the hundreds place, this will give me 83.138, so 83.14. And again, still units. Now I'm going to calculate the area. The formula for area, 1/2 apothem times perimeter. The apothem is 8. It was given to me. The perimeter I just calculated. It's going to be, and I'm going to use the radical form. I don't want to use the rounded form yet. I'm going to go ahead and multiply. 1/2 of 8 is 4, and then 4 times 48 is 192 square root 3 units squared. Now using my calculator, 192 times the square root of 3, rounded to the hundreds place, 332.55 units squared. So again, I need to find the value of n, which is 6. I know the s, it's 12. This time I'm solving for the a. I don't know the apothem. So let me go ahead again and draw my hexagon. Again, I like to put 6 little dots and try to space them out. Connect them to make your hexagon. Draw in the radii. Figure out the central angle, 360 divided by 6, and I get 60. So again, the measure of the angle up here is 60, but remember, as soon as you draw in that apothem, it's going to bisect that 60. So now the triangle we're dealing with is a 30, 60, 90 again. So it's got 30 at the top, 60 at the bottom, and then the right angle. And again, they gave us the side length this time. So this whole side right here is 12. Remember, the apothem bisects it. So this is going to be 6 and 6. So over here is 6. Remember, you're memorizing that the side across from 30 is x, and then the side across from 60 is x square root 3. This is 2x. All I need to do is take my x, put it in front of the root 3, and that will give me my apothem. Now I have the 3 values of the variables, so now I can plug them into the formula. So again, for perimeter, number of sides times the side length. This was given to me from the beginning. So 6 times 12, and I get the perimeter to be 72 units. For the area, I'm going to take 1/2, multiply that by the apothem and the perimeter. So 1/2, the apothem is the 6 square root 3, and the perimeter is 72. I need to multiply these 3 numbers, 1/2 times 6 square root 3 times 72, and I end up with 216 square root 3 units squared. I'm going to go ahead and use my calculator. 216 times the square root of 3, rounded to the hundreds place, is going to give me 374.122, so 0.12. And this is units squared. So we have the perimeter, and then we have both versions of the area, the exact and the rounded answer to the hundreds place. Next, we have a square with a diagonal of 10. Let me draw a square. So I have a square. I'm going to draw in my diagonal. And it tells me it has a length of 10. Now, remember that when you have a diagonal in a square, the diagonals are congruent because it's a rectangle, and they're also bisected. So that tells me that this side here is a 5 and a 5, and this could also be a 5. So what I'm going to do here is, these are also my radii. I'm going to find the measure of my central angle. I take 360, divide it by the number of sides, which is 4. And this tells me that this angle up here is 90 degrees. Once I draw in my apothem, it's going to bisect that 90. And now it's going to make this a 45, 45, 90 right triangle. So I've got this and this and my right angle. So what they've given us this time is the hypotenuse. This is 45 because the 90 was bisected. Remember, in the 45, 45, each of the legs are congruent, and the hypotenuse is x square root 2. So what we can do here is solve for x. So x square root 2 equals 5. Divide by the square root of 2. X is equal to 5 over the square root of 2. I need to rationalize. X is equal to 5 square root 2 over 2. This is going to be this x and this x. Notice the blue x, this is my apothem. This is only half of the side, because remember, it's right here and right here. In order to get the full length of the side, we need to add these. Either that or times it by 2. Either way. So once I add these, I actually get 10 square root 2 over 2, which simplifies to 5 square root 2. That's the side length. So now I have my n value, it's a square, it's 4. My side length is 5 square root 2. my apothem is 5 square root 2 divided by 2. I'm going to show you how to calculate the area of this square two ways. We're going to use the formula that we learned back in elementary school. You learned that the area of a square is really just side times side. So really, we don't need the whole 1/2 apothem times perimeter. When it's a square, I can just do side to the second power. So if you just want to do 5 square root 2 squared, this is going to give us the same answer as using the polygon formula. So what I'm going to do here is 5 square root 2 squared means write it 2 times and multiply it. So you would do the 5 times 5, get 25. And then root 2 times root 2 is just 2. So the area of this square is 50 units squared. For perimeter, I'm going to use the same formula. Perimeter is number of sides times the side length. So for the perimeter, 4 sides, the side length was 5 square root 2. So for the perimeter, it's going to be 20 square root 2, and these are units. Now, let me show you how to do the area using the polygon formula. So you can either do it this way or do it 1/2 apothem times perimeter. The apothem was 5 square root 2 divided by 2. And then remember the perimeter was 20 square root 2. So you can see that just squaring the side is a lot faster than doing the full formula when it's a square. So after I multiply these, I end up with the same answer, 50 units squared. Because watch what could happen here. I could take half of 20, change that to a 10, and then what I could do is 5 times 10. Actually, I could take half of 10 again and make that a 5. And now do 5 times 5. And then root 2 times root 2, which is 2. And I get 50. So again, either formula when it's a square, as long as you know the side length. Now we're going to do a pentagon. Now, again, hexagon, equilateral triangle, and squares are the only ones that you could do with a special right triangle. Pentagons, octagons, decagons, all those others are going to need to use your trigonometry. So let's go ahead and draw a pentagon. Again, just do it the best that you can. I'm going to just put 5 dots and then connect them. Draw in my center point. Draw in my 2 radii to create my central angle. Remember, to find the measure of this central angle, we take 360 and divide it by the number of sides. You need to know that the end value when it's a pentagon is 5. 360 divided by 5 is 72. This central angle is 72 degrees. Once I bisect it with my apothem, this angle up here now is 36 degrees. It's not a special right triangle. So this is why I have to use the trig. I'm going to label what was given to me. It was given me the radius. So this radius has a measurement of 8. So what I'm going to do now is pull the triangle out. And I've got an 8 here, got the right angle, and then I've got the 36 degrees. I'm going to label the sides of this triangle based off the 36. The 8 is the hypotenuse. The side over here, I'll call this X, is the side opposite to 36. And then my apothem over here, this is my adjacent side. So to find the side opposite, I'm doing the so, ka, and toa. So notice to find the side opposite to the 36, which is half of the side, I'm going to be using so, because it's opposite and hypotenuse. So sine of 36 is equal to opposite over hypotenuse. I'm going to solve by multiplying both sides by 8. And 8 times the sine of 36 gives me 4.70. I'm going to round it to the tens place, so 4.7. That's this side, which is half of the original side, so I got to double it. So 4.7 times 2, and the whole side together is 9.4. So far we had the n, we just found the side, it's 9.4, and now I need to find the apothem. For the apothem, I'm using cosine because it's adjacent and hypotenuse. So for that one, I'm going to do cosine of 36 is equal to the a over the 8, multiply both sides by the 8, and cosine of 36 times 8 gives me 6.47, so rounded to the tenths, 6.5. Now I have the 3 values of the variable, and I need to plug it into the formulas. So for perimeter, number of sides times the side length. 5 times 9.4 gives me a perimeter of 47 units. For the area, 1/2 apothem times perimeter. So 1/2. My apothem I found to be 6.5, and the perimeter was 47. Go ahead and multiply those 3 numbers, and you're going to get 1/2 times 6.5 times 47 gives you 152.75, and these are units squared. We're in octagon now. So again, I already know my n value, it's 8. My side length is 10, and I don't know the apothem. This is what I got to find. So if I put 8 little dots around my circle here, so 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Doesn't have to be perfect. Put in a center, draw in the 2 radii to create the central angle. I'm going to take 360. I'm going to divide it by 8 because that's how many sides are in an octagon. Once I do that, I get 45. Remember, 45 is the whole thing. Once I draw in the apothem, it splits that 45. So it's 45 divided by 2, and that angle up at the top is 22.5. So now what I'm going to be working with is just this, with a 22.5 angle up here. You were given the side length, and again, remember the apothem bisects it. So it said it was 10, so this side is now 5. And I'm going to label the sides again in relation to the 22 degrees. So this is opposite, this is hypotenuse, and this is adjacent, which is also my apothem and what I'm looking for. So I'm going to go ahead and fill in. They gave me the 5. So I want adjacent and opposite. That's TOA. So I'm going to be doing tangent. So the tangent of 22.5 is equal to opposite over adjacent. Remember, when the variable's in the bottom, we're using division to solve. So what I'm going to do here is multiply both sides by a to get it out of the bottom of the fraction. So now I have tangent 22.5 times a equals 5. Divide both sides by tangent 22.5. And A is equal to, so 5 divided by tangent 22.5, and I get rounded to the tenths place, 12.07, so 12.1 is my apothem. Now that I have the value of the three variables, plug it into the formulas. Now notice it only said area, but I'm going to go ahead and do perimeter as well. Number of sides times side length. Number of sides in an octagon is 8. The side length was given to me, it was 10. So the perimeter is 80 units. Next, I'm going to plug it into the area formula. 1/2 apothem times perimeter. I just found the apothem to be 12.1 times the 80, which is the perimeter. And once I multiply, I am going to get 484 units squared. And that is it for the notes.